Tonight, you'll probably look up and see it without even trying. A pale circle hanging over your street. You won't think about it. You never do. But if that circle vanished tomorrow, most of what keeps you alive would start unraveling within days. Not years. Days. That sounds impossible. The moon feels like scenery, a backdrop, something pretty that shows up in photos and poems and nothing else. But the real answer is far stranger. The moon is not decoration. It is a machine. And you have been living inside its output since before you were born. Start with the obvious thing. Tides. You know the moon pulls the ocean back and forth. Maybe you learned that in school and forgot why it mattered. Here is why it mattered. Tidal mixing turns over nutrients from the ocean floor. It feeds plankton. Plankton feeds fish. Fish feeds nearly 1 billion people who rely on seafood as a primary protein source. Pull the moon away, and tides don't stop completely. The sun still tugs at the water, but the pull weakens dramatically. Coastal ecosystems that evolved around a strong tidal rhythm would begin to collapse within a single generation. That's the fast damage. The slow damage is worse. Here's something most people never learn. The moon doesn't just move water. It stabilizes the tilt of the entire planet. Earth spins on a 23.5-degree axis, and that tilt is why you get seasons instead of permanent extremes. Without the moon's gravitational anchor, that tilt would wobble. Not gently, wildly. Researchers modeling this exact scenario, including planetary scientist Jack Lissauer at NASA Ames, found that Earth's axial tilt could swing anywhere from nearly 0 degrees to over 85 degrees over the course of a few million years. 0 degrees means no seasons anywhere. 85 degrees means your hemisphere could tip into total darkness for months, then total light for months, on a rotating and unpredictable cycle. Think about what that means for agriculture. Every crop cycle humans have ever built, every harvest calendar, every migratory pattern in nature assumes a tilt that stays roughly where it is. Remove the stabilizer, and you remove the assumption underneath civilization. You're probably wondering how one relatively small object, a quarter the size of Earth, sitting almost 240,000 miles away, has that much leverage. Here's the plain version. Gravity isn't about size alone. It's about consistency. The moon has been tugging on Earth's equatorial bulge for over 4 billion years, like a gyroscope keeping a spinning top from toppling over. Take away that steady hand, and the planet has nothing correcting its wobble anymore. Chaos isn't dramatic. It's just math with no breaks. Now here's the part almost nobody talks about. Days would get shorter. Much shorter. The moon is slowly stealing Earth's rotational energy through tidal friction, which is why days have been getting longer by about 1.8 milliseconds per century, a phenomenon confirmed through decades of data compiled by researchers at institutions like the U.S. Naval Observatory. Billions of years ago, a day on Earth lasted around 6 hours. Remove the moon today, and that braking effect disappears. Earth would gradually spin faster again. Hurricane force winds, driven by a faster rotation and stronger Coriolis effect, would become the planet's new normal weather pattern, not a rare disaster. Pause here, because this is where the story stops being about rocks and orbits and starts being about you specifically. Human beings evolved under a very particular rhythm, a 24-hour day, a tide that moves twice daily, a moon that changes shape in a predictable 29.5-day cycle. Your circadian biology, your sleep hormones, even certain reproductive cycles in other species quietly synced themselves to that rhythm over millions of years. Biologist Charles Darwin himself noted the strange precision of lunar-linked behavior in marine organisms, and modern chronobiology has only deepened that picture. Coral spawning events, insect mating windows, and nocturnal predator behavior all lean on moonlight as a timing cue. Remove the moon, and you don't just remove a light source, you remove a clock that ecosystems have been checking for longer than humans have existed. Does that sound abstract? It isn't. It's happening in a smaller version right now. Light pollution from cities already disrupts lunar-based behavior in sea turtles, migratory birds, and moths, according to field research published by ecologists studying artificial light at night. A full disappearance of the moon would be that same disruption, but permanent, and everywhere at once. Here's the twist most people never expect. The moon isn't just protecting Earth's rhythm. It might be part of the reason Earth has complex life at all. There's a theory, most associated with planetary scientists studying the rare Earth hypothesis, that a large, stabilizing moon may be a rare requirement for long-term habitability on any planet. Without it, a planet's tilt can swing so unpredictably that surface conditions never settle long enough for complex organisms to evolve. If that theory holds, the moon isn't a bonus feature of Earth. It might be a precondition. The quiet, unglamorous engineer that made the rest of the story possible. So what would actually happen, step by step, if the moon vanished tomorrow? Within hours, tides would drop by roughly 2/3. Within weeks, coastal fisheries would show measurable decline. Within a year, nighttime would turn genuinely black, since the moon is responsible for almost all natural nighttime illumination. Predator-prey behavior that depends on that faint light would shift immediately. Within a decade, faster rotation and weaker axial stability would begin altering storm intensity and length of day, subtly at first, then unmistakably. Within a few 100,000 years, the wobble would compound, and climate zones you currently rely on for food production could shift into unpredictability. None of this requires a science fiction disaster. It just requires removing one steady variable from an equation you never knew you were solving. Here's the strange part to sit with. You've probably never thanked the moon for anything. It doesn't heat your home, it doesn't grow your food directly, it doesn't send you a paycheck. But it holds the tilt that gives you spring after winter. It slows the spin that keeps your storms survivable. It sets a rhythm that your own body still quietly follows, whether you notice the moon or not. Tonight, when you glance up and see that pale circle again, you probably still won't think about it. Most people don't. But now you know what you're actually looking at. Not scenery, not decoration. The quiet machine holding your whole world steady.